Okay, it's time for your Friday video. So September the what, 25th, I believe. Okay, so let's just go share the screen. We're going to kind of keep going with graphing of functions. Okay, so let's see if I can get the screen to share with us. All right, so we're going to kind of start with a reminder of what we've done. So the first few slides aren't going to be anything new. You've got these basically in your notes already. Okay, but I do want to remind you so that what you're doing now will make a little more sense to you. Okay, so this would be my advice when you're graphing functions. The first thing I would do is I would know the basic shapes of those common graphs that we went over in class last time. All right, so when I say y equals a constant, remember that's y equals a number, like y equals 4 or y equals a negative 1/2. So when you've got y equals a constant, remember you got that horizontal line. Y equals x, remember that's that one that splits the first and third quadrants. Y equals x squared is that parabola. Y equals x cubed is that S curve. Absolute value, remember, is that V, and then square root of x is like half of a parabola. So I would know those basic shapes, those common graphs. Then I would make a t-table, just a 2-column table where you got your input, your domain number like your x, and your output like your y number, your range. Now, where it says be aware of the transformations of the common graphs, that's what we're going to be talking about in just a second. That's kind of the stuff that's new. And then, like we talked about at the end of class last time, once you got your graph there, once you've drawn it, kind of notice where it increases and where it decreases, and look at the x numbers it increases between, or the x numbers it decreases between. Okay, that's the way they'll kind of phrase it. And then notice where you got your highs, your maximums, and your lows, your minimums. Okay, let's go look at the next slide. All right, these are the common graphs. Again, just a quick reminder. I did y equals 2. So remember, that's again like we did in class. That's just a horizontal line that's 2 above the y-axis. So no matter what you put in for x, that y value is going to be 2. Okay. Now remember, we also did that identity function where you had y equals x. So they match. So whatever x is, if x is a negative 2, y is going to be a negative 2. If x is 1, y is going to be 1. So that's the one we said where y equals x, it splits that graph, that quadrant 1 and quadrant 3 in half. So you should know that. Absolute value, remember we talked about, it's that V thing, okay? And absolute value, never going to have negative numbers for the y coordinates. It'll either be 0 or a positive number. So all these three are already sketched in your notes, okay? The next three are also already sketched in your notes, but a quick reminder. You've got your quadratic y equals x squared, so that's that parabola. So it looks like that V curve, but it's not straight. Remember that absolute value is straight. This is curved, okay? And again, how many values should you put in for x? I can't tell you that. If you've done it a good bit and you know the basic shape, you only may need 5 or 6. If you've never graphed very much, you may need 12. I mean, you just have to keep doing the points until you feel comfortable connecting the dots and getting the basic shape. That cubic function, that cubed, I know I'm going to get an S curve, okay? So again, this is already in your notes. And then that square root function. So remember your domain, you can't have negative numbers under that root, so I wouldn't be able to put any negative numbers in for x, okay? So those 6 graphs are already in your notes, all right? So now we're going to kind of start the new stuff, the transformations, okay? So here's what you know. There are things called vertical shifts, like it takes your basic common graph and moves it up, or it takes that basic graph and moves it down. And how you know you have that is, notice, I've still got y equals f of x the way I did before. It's just I've got a number added at the very end or a number subtracted at the very end. But I've still got my original y equals the square root of x, or y equals absolute value of x, or y equals x. Now in this example, I took this basic shape y equals x squared, okay? So y equals x squared, remember, is a parabola. That vertex is the origin. This is the one that we've already got graphed in your notes, okay? Now I want to graph y equals x squared plus 4. So notice, this looks just like that part right there. The only difference is I've got this plus 4 stuck on the end, okay? So what that's going to do, notice what it says, when you have plus a number, if that number is positive, we'll talk about why in a minute. If you're adding a positive number, it's going to shift this graph up that many spaces. So that whole graph is just going to move up 4 spaces. So I want you to notice something. Do you see how 0, 0 right here is the vertex? Well, what would happen if I went up 4 spaces? I'd go up 1, 2, 3, 4. Do you see how this point would move up to here? And see, sure enough, if you go over here and you plug 0 into this graph, 0 squared plus 4 is 4. So instead of getting the point 0, 0 on this graph, we get the point 0, 4 on that graph. Look, just like I said, it's 4 up. So this one, where I have -1 here and I got 1, this one's going to be -1. It's going to shift it up 4. So if I went over and went up 4, I'd be at 5. So if you substitute -1 in here, -1 squared is 1, and 1 plus 4 is 5. So notice all of these y values and the difference in all of these y values. Do you see how when you add 4 to that, you get 8? When you add 4 to 1, you get 5. When you add 4 to 0, you get 4. So you've got a choice. You could just ignore this and come over here and just substitute all these numbers into that graph and draw your basic shape. But what you should know before you start, you should expect this to be this graph and the whole thing just moved up. The whole thing just shifts up 4. So that helps you kind of know when you plug in your numbers here if they're correct. Okay? Now, that's if you're adding a positive number. Now, what if you're subtracting a positive number? So instead of shifting it up, then it's going to shift it down. Let's go look at one. Okay. All right. Let me come up here, maybe. Okay. And get my thing back. So look at this one. Well, let's go back. It didn't want to do that. Let's try it again. All right. So this time I've got y equals x cubed minus 1. Now look what that's going to do. Remember your basic shape of y equals, there it is, y equals x cubed. That's what that basic shape looks like. So what's going to happen when I want y equals x cubed minus 1? It's going to take this graph and it's going to drop everything 1. So the point 0, 0 is going to drop 1 to become the point 0, -1. 1, 1, instead of being 1, 1, it's going to drop it 1. So it's going to drop it right there and be 1, 0. So this -1, -1 drops down 1. Now it's -1, -2. So see, it looks like the same graph just got shifted down. So when you're adding a positive number, it shifts up. When you're subtracting a positive number, it shifts down. But you could go and just substitute the numbers in. When you substitute in a 0, 0 cubed is 0, minus 1 is a -1. So again, you would come over here. I didn't do it because I didn't have enough time, but you come over here and just make again. Like I said, that first couple of steps. I know the basic shape, but I basically come over here and I just substitute numbers in. If I put 0 in there, I'm going to get a -1. If I put 1 in there, 1 cubed is 1, minus 1 is 0. If I put 2 in there, 2 to the third is 8, minus 1 is going to give me 7. So I could just plug in enough numbers till I felt good drawing my graph. Now, here's what I said. Notice, if you had x squared plus a -3, isn't that the same thing as x squared minus 3? Isn't this just a way of writing that? So just because it's got a plus doesn't mean it's going to shift up. You have to be adding a positive number to shift up. That's really the same thing as subtracting a positive number, so the graph shifted down 3. Okay, so plus positive numbers goes up, minus positive numbers goes down. Okay, now that's kind of what we call our vertical shifts. All right, let's move to our horizontal shifts, because sometimes instead of shifting up and down, it's going to shift left and right. All right, so let's go look at this one. This one's not as intuitive to me. It almost seems backwards. Okay, so it's going to be real important that, and I purposefully didn't fill all that in. We're going to fill it in as we go, okay, to kind of show you. If it's got, now notice the plus C is not at the end. The plus C is inside the graph, okay, with the X, or the minus C is inside the function with the X. Now, what do I mean? Now, remember before we had y equals x cubed and we had like the plus 3 stuck at the end. Well, see, that's not what this is. This is stuck in with my x, like that minus 3 is in the parenthesis with the x squared. So when you've got something like y equals, and you've got x cubed, remember that's your basic S curve. And then they've just got a plus 3 stuck at the end. All right, I'll tell you what, let's do this. Let me go erase this one. And let's make it this. All right. Let me go back now and get my pointer. Okay, let's try it again. It doesn't want to cooperate. Sometimes it does and sometimes it doesn't. Okay. So let's make it x squared, and let's make this a minus 3 instead, so it'll kind of match. If it were y equals x squared, that's my basic parabola, and that minus 3 is stuck at the end. So that's going to be a shift either up or down. Because it's subtracting a positive, it would shift down. See the difference between where this minus 3 is and where that minus 3 is. This minus 3 is in the parenthesis before you square it. So it's going to shift it left or it's going to shift it right. Now, a lot of times we think, oh, it's minus, so it's going to shift left, but it doesn't. See, look what happens. If I put a 1 into this graph right here, 1 minus 3 is a negative 2. And when I square a negative 2, I get a 4. What happens when I put a 3 in there? Well, 3 minus 3 is 0, and 0 squared is 0. Well, what happens when I put a 4 in there? Well, 4 minus 3 is 1, and 1 squared is 1. All right? So when I put a 0 in there, 0 minus 3 is going to give me what? A negative 3. But what happens when you square a negative 3? When you square a negative 3, you're going to get a 9. All right, what would happen if I stuck a 1 in there? Well, 1 minus 3 is going to be a negative 2, and so when I square that, I'm going to get a 4. All right, what happens when I put, excuse me, that was a negative. Oh, let's fix it. I did that wrong myself. I already did 1, 4, didn't I? All right, so let's kind of get rid of that. What if I did a negative 1? If I did a negative 1 minus 3 would be a negative 4. And when you square a negative 4, you're going to get 16. So I could do all of these, but look what happens when I start graphing. I've got 0, 9, I've got 1, 4, I've got 3, 0, I've got 4, 1. I could go do 5 and I would get a 4. Look at this graph. This one didn't shift left. This point right here went to the right. So it's counterintuitive to me. So when there's minus a negative inside, minus a positive inside that parenthesis, it's actually going to shift the graph to the right. Okay. If it had been plus 3, it would have shifted it to the left. All right. So let's kind of go get some more and look at another one. Let's go get my pointer again. All right. And I did kind of a similar one right here. We know that we've got, should be a y right there equals x squared. So let's fix that so you can fix it in your notes. Okay. So change this, it should be y. It looks like an x. It's not a very good y. So y equals x squared is my basic graph. So y equals x squared, and with the plus 1 in the parenthesis, I know it's going to shift it 1, but it's not going to shift it 1 to the right. It's going to shift it 1 to the left. So that point goes to right there. This point is going to go over here to right there. This point's going to go 1 over to right there. And so sure enough, look, it shifted it over. So you can just substitute those same numbers in and get your y values back out. All right, now we got one more transformation to kind of look at. So let's clear all those markings. So when I go to the next one, they won't be on there. Okay. All right, look at this one. Look what happens when you have a negative in front. It takes your graph and flips it across the x-axis. All right, so look what I did. Here's what I'm saying. We know what the graph of y equals x squared looks like. It looks like this graph right here. All right, so look what happens. It's like somebody took that blue and flipped it upside down. So this down here is the graph of y equals a negative x squared. Now remember, an exponent only goes with what immediately precedes it. So that's not the same thing as this. We've talked about this in class before, but let's reiterate it. All right. It makes a difference if that negative is in the parenthesis or that negative is outside the parenthesis. So this just means I've got a negative and I've got an x times, and I've got another x. So the only thing that's multiplied by itself twice is just x, not the negative. Over here, what precedes that exponent is the whole parenthesis. So that's going to be that negative x. That's one parenthesis times another parenthesis. Okay? So do you see how they're different? Well, over here, a negative x times a negative x would be a positive x squared. So make sure you understand we're graphing this one. The negative's just in front. It's not in a parenthesis. So look what would happen if we put a negative 2 in there. A negative 2 times a negative 2 is a positive 4, but now I've got a negative in front of that. All right, so I've got a negative, and then I've got a negative 2 times I've got another negative 2. So a negative 2 times a negative 2 is a positive 4, but see, I've got a negative in front of that positive 4, so that's why it's a negative 4. So the same thing, if I take that negative 1 and I square it, you're right, I'm going to get a positive 1. But now I've got a negative in front of that positive 1, so I've got a negative 1. So if I graph negative 2, negative 4, I'm down here, negative 1, 0, 0, 1, negative 1, so now my graph flips down. So anytime you take one of your common graphs and you stick a negative in front of it, it's like you just flipped it across the x-axis. Okay? All right, so let's go look at this other thing real quick. Let's go kind of do a review. Okay? Here's kind of my review. And again, you can freeze it, just like usual. And I kind of numbered it to go with my examples. Okay? So the first transformation was a shift up or a shift down. So that was the very first one. That's why it's numbered 1. And you have like a 1A where the example shifted the graph up, and you have a 1B where it shifted it down. So do you see how the plus and minus of those positive numbers is just stuck at the end of your regular graph? And if it's plus C, it's going to shift it up C units. So plus 4 would shift it up 4. If you did minus 5, it would shift it down 5. So that's what that means. Okay, now, if you've got the plus C and the minus C inside the parenthesis with the X, that's not going to shift it up and down. That's going to shift it either left or right. Okay, and that was the second kind of transformation that we went over. So I numbered it 2 to go with your examples. So when you got a plus C in the parenthesis, it actually goes to the left, which to me is kind of backwards, kind of counterintuitive to what I think it might do. And then I told you, if you've got your regular graph, but you got a negative in the very front of it, it's going to flip it across that x-axis. Now, these shifts just make it a quick way to double check your t-table. You still need to make t-tables. You substitute in, you know, if you get a square, you're going to have a parabola somewhere. If you've got absolute value, you're going to get a V. You know, if you've got a cubed, you're going to get an S-curve. You just know if you've got some numbers either added into the parenthesis or added on the outside, it's going to be that basic graph shifted. So this is just a way to double check your answers or to kind of let you know what you should expect, but you still need to do those t-tables. Okay? All right. Now, let's go look at something real fast. It doesn't want to do. Let's try it. Come back up here. There we go. Now, let's go look at an example about something. All right, look what this one says. A package of food is removed from the refrigerator. The number of bacteria in the food can be calculated by this equation. B for bacteria, so I said let bacteria be the B, is 90T squared plus 600, where T is the number of hours the food's been out of the fridge. You know, when you take food out of the fridge, if you leave it out too long, you get a lot of bacteria and you can get food poisoning. You can get salmonella. So you really don't want to get food poisoning. So it matters how long things have been out of the refrigerator, okay? So this formula, if I know the T is the number of hours that it's been sitting out, and then B is how much bacteria is growing on my food. So look what I said. I said, find the number of bacteria in the food when it's been out of the refrigerator for 3 hours. Now, what is that 3? Is that my time or is that my bacteria? See, that's the time it's been out of the refrigerator in hours. So I put 3 in for T. Well, when you remember order of operations, you don't have anything inside of a parenthesis to do. So the next thing I look for is exponent. So I had to do the exponent first. 3 squared is 9. So remember what comes next after exponents, multiplication, division. So I do the multiplication first. 90 times 9 is 810. And when I added the 600, that would get me 1410. That's the number of bacteria that would be on my food. All right. Then I kind of changed the question. Find the approximate time when the bacteria reaches 2,400. Okay. So this time, what's the 2,400? Is it my time? It said when the bacteria reaches, it said find the time. So this time I'm trying to find T. So that 2,400 is my B. So I put 2,400 in place of B. Well, if I want to get the variable by itself, I had to get rid of that 600. So just like before, if you subtract 600 over here, then I got to subtract 600 over here. So that's what I did. I went over here and said 2,400 minus 600, and I got 1,800. And then, of course, those go out. Okay. So, you know, those go out to 0. So that leaves me with my 90T squared. Now, I was running out of room, but does everybody understand what I did right here? I wanted to get rid of the 90. So wouldn't you have to take this number and divide by 90 and take that number and divide by 90? So when you would divide by 90 on this side, and then I'd go over here and I would have to try to do it real small. I would divide by 90 over here. So 1,800 divided by 90 is where I got the 20. Then, of course, 90 divided by 90 goes out to 1 and leaves me my T squared. Now, what would I do? How do I get rid of that 2? Well, I could take the square root of both sides. Now, remember, when you take the square root, I'm going to get 2 answers, a positive or a negative. Now, so T comes out to be 2 answers, but I threw one of them away. Now, you could either get a positive or you could get a negative. Now, I had to round it off, all right? So it didn't come out exact. I just kind of rounded off to about 4.5 hours. Why did I throw that negative away? It's missing. Why did I make it missing? There are 2 math answers, but only one makes sense in this context. I can't have a negative time. So that's why I threw that away. And then remember, if you round, you want to warn somebody that it's approximately that. Not exactly that time, but approximately 4.5 hours. So I could go look up, I could go Google, you know, what number of bacteria is problematic for a person. You know, your body can fight some bacteria. And if I knew that your body couldn't handle more than 5,000, you know, the number 5,000 in bacteria, then I would put a 5,000 in there so I would know how long I could leave my food out. So I don't know what that number is. So that might be a good thing to do. Go Google and see how much bacteria your body can handle so you know how long to leave food out. Now, do you understand if I told you to graph this graph? That's a basic shape. I've got a squared. So I would know that I'm going to have some kind of parabola, but it's not going to be here. It's going to be, they're going to take this parabola and it's going to be shifted way up here because I'm adding 600 to it. So it's going to get shifted way up. Now, we'll talk about this later, but that 90 in front of the T squared either makes this curve like more slender or makes it wider. All right. So if I had the graph, I could look and see where the graph crossed at 2400 to figure out what my time was. Okay. So you're going to have some homework on Moodle. So I need you to kind of go look at it. All right. If you're having any trouble, then make sure that you let me know on Monday. But basically, you're still going to draw the same graphs. You're going to use T-tables. It's just you need to know kind of what you expect to get in your head. That for vertical shift, they're adding a positive number at the end or subtracting a positive number. For horizontal shifts, they're adding or subtracting numbers inside the parentheses. Okay? So hopefully you'll have a great weekend. All right, so let me kind of stop this sharing. We don't need that screen anymore. And I will see you on Monday. I hope you have a great weekend.